All right, here we go. Video number 5. I thought I'd work out some review problems from the book, thinking that might be helpful to you. So this is number 30 on page 339. And we see it's the integral from 0 to 1 of t times the quantity 5 to the t squared dt. So we're going to go ahead and pick u equals t squared. Du, or I should say 1/2 du, is equal to t dt. Okay, so this becomes the integral. Let's see, I have t dt there. 5 to the u du with a 1/2 out in front. Okay, did I do that too quickly? So here's the power of the base of 5, and then t dt is nothing more than 1/2 du. All right, so now what we have to do is change the bounds. Bounds used to be 0 and 1. My favorite type of problem, when I square 0 and 1, I still get 0 and 1, so that's great. So now what we need to do is take the integral of 5 to the u, and that is equal to 5 to the u over the ln of 5. Okay, we're going to evaluate that at 0 and 1, and so we get 5 to the 1 over 2 ln 5 minus 5 to the 0 over 2 ln 5. And I just want to make a note here is that we sometimes get lazy and assume that when the lower bound is 0 that the thing we subtract is going to always be 0, and so we forget about it. But if we think about it, 5 to the 0 isn't 0, it's equal to 1. And so our final answer is 4 over 2 times the natural log of 5. All right, hopefully that makes sense. Great, here we go, we're moving on. On page 354, here was a fun problem I found, number 50. And this time it is an integral without bounds, e to the negative 2x sine of e to the negative 2x dx. And this one might be a little tricky in the beginning to determine what you should pick, and so we're going to go ahead and pick u to be e to the negative 2x, the argument of the sign. That makes du with the chain rule negative 2 e to the negative 2x, or negative 1/2 du, oops, left my dx off, equals e to the negative 2x dx. All right, so matches up nicely. I have e to the negative 2x dx, and this becomes the sine of u with a negative 1/2 in front du. How's that work out? Okay, so here's what we're going to do is we're going to take the antiderivative of the sine, which is the negative cosine, right, and plus c, because it's an indefinite integral. The negatives take care of each other, and I get cosine of e to the negative 2x over 2 plus c as my answer. Okay? All right, let's do one more, and this one is number 43. Believe on the same page. I didn't write the page down. Hopefully it's number 43. This time is a definite integral with exact values. We like those. We've got the sine of theta over the cosine of the 2/3 power of theta, d theta. Okay, so what should we pick for u, the cosine or the sine? I'm going to go ahead and pick u to be the cosine of theta, thinking that it's being taken to the 2/3 power and it's in the denominator, so those are two flags that go up that tell me to pick cosine theta as u. That would mean that du would be the negative sine theta d theta. Make sure before you take this test that you've got your derivatives and integrals straight, the ones we have to have memorized. So the opposite of du is equal to sine theta d theta. So we're going to rewrite this as, let's see here, sine theta d theta, that's my negative du, and then this becomes u to the negative 2/3 power, right? Because u is the cosine of theta. I've got cosine 2/3 power of theta in the denominator, and that's what I need to integrate. Before I go any further, I have to go ahead and change the bounds. So cosine of 0 is 1, right? And the cosine of pi over 3 is 1/2. Some of you might want to flip the sign here, rewrite it as the positive integral from 1/2 to 1 of u to the negative 2/3 d theta du. Okay, that's perfectly acceptable. It's not necessary. I think when you change it here, you have less chance of losing that negative when you actually integrate. Okay, and so here we go. We're going to use the power rule. So that would be u to the 1/3 dividing by 1/3 would give me 3 u to the 1/3, and I'm going to evaluate that at 1/2 and 1. Okay, the evaluating it at 1 is pretty easy. That's just simply 3. At 1/2 we would take 3 times 1/2 to the 1/3, and without a calculator that would be your final answer. Okay, I hope that these review problems, going through them, you have the ability to stop as I'm explaining, rewind it. I hope that this is making U substitution more clear and that you'll be ready for the upcoming test. Okay, see you in class.